In this video, I'd like to demonstrate for you the idea of trans-track or transformation tracking. So the idea is that you monitor the position and orientation of one object while it moves through space, and you can do that in multiple different ways within SA. One of the ways that you can do that is to use three separate instruments, all measuring at the same time. And I have a file set up here to demonstrate that idea using effectively a wing join operation. So the idea is that I'm going to take this little model of an airplane. It's actually a scaled model of an A380, and I'm going to monitor its position in space and move a wing as if you are performing a wing join operation. So the first thing that you need to do in order to perform this is to measure where the wing currently is. And you have to have at least 3 points on the wing that you're monitoring, one for each instrument, and that provides enough information to be able to actually track its position in space, both in position and in orientation. So step one is to measure a single point, defining where the reflector is in space from each of the individual instruments. And what I'm going to do is put them all in one group, and this allows me to perform a best fit. Because what I have to do here is actually move the pre-assembled airplane into its current position. So that's the first step, is I have to define where the reflectors are now and then move the wing over to them so that you have a starting position. So I have this already set up in this job file. So this wing and all of its associated pieces are in a single collection, which kind of makes things easier. So I can just simply do a best fit to align the actual locations on the wing to my measured locations of where the wing is on the table below the airplane. So here we go. And when I do that, you can see I also set up some other things. I have a couple of vector groups and a couple of dimensions, if you can see those down there, to help guide the assembly process and to visually indicate the deviation between where the wing is and where I want it to be. The other thing I did was construct a frame, and this frame allows you to build a relationship, and you can add a watch window looking at the relationship between two frames, which is nice because it gives you both position and orientation information so that you can get a graphical readout of the XYZ position and the RX, RY, RZ rotation of the wing in real time. So now what I'm going to do is go up under transform tracking and select the option to use three separate instruments. Now this is the next important thing, is you have to select the three instruments in order and the 3 points that they're monitoring in order so that you don't have the model flip upside down monitoring the wrong point. Just a little detail there for people who are trying to get this started for the first time. But once you have the instrument and the point that it's monitoring, you simply have to hit the query button in this little dialog, and if you'll notice, it looks at updates from the instruments. And depending on the update rate and how fast it's getting data from the instruments, it will compute a frame position based upon those three locations, and that gives you enough information to track the wing as it moves through space. And it goes increment by increment. Each time there's an update, it's actually performing a full frame-to-frame transform, and it's moving everything that's in the moving collection in this job file, and you can simply watch it move through space and come into orientation. So what's amazing about this, even though this one is actually just a scaled graphical model, is that it can be done with a real aircraft, and it can guide you directly into position as you align your wing into position within a very tight tolerance, because having three separate reflectors spread out upon a wing and monitoring them with three separate instruments provides amazing angular accuracy as well as position information.